Okay, and we're ready to go. All right, so starting off today's lab, we had 5 questions to start off with our bell ringer. The first one says, what is an element? Who can tell me what an element is? What do you think, sir?
An element is a substance that cannot be separated into a simpler substance by chemistry.
Something that cannot be separated into a simpler substance. I've also seen a definition that says a substance that is made of only one type of atom, like all copper, all cobalt or nickel, right, aluminum, all the different elements. It can't be broken down. So if I were to look at something as simple as this water, all right, you can't really see it here. This water right here. This water has 2 elements in it. Does anyone remember what elements make up water? Hydrogen and oxygen, right? So both hydrogen and oxygen are in this water right now. They're bonded together. Can we separate those? Yeah, yes we can. We split those atoms apart and we make hydrogen gas. That's how some fuel cells work off water, or actually split water. Okay, so let's do number 2. What do we call 2 or more atoms bonded together? Just like this water. You got 1 oxygen and 2 hydrogens. They bond together to form 1 blank of water. Starts with an M. Molecule, exactly. A molecule is 2 or more atoms bonded together. So this water has thousands upon thousands and trillions and billions of water molecules. 1 oxygen with 2 hydrogens. Right? A molecule. Next up, which state of matter has a definite volume but doesn't have a definite shape? Yes, ma'am.
Liquid?
A liquid, exactly. They say liquids take the shape of their container. They have a set volume, so if I have 12-ounce can. If I have 12 ounces of Dr. Pepper, it doesn't matter if it's in this can or if I pour it in this bucket, it's 12 ounces, right? So that is a volume measurement, and it stays the same, but the shape does not. What state of matter has both a solid or constant... sorry, guys. Oh, leftover lunch. Has a constant volume and shape. Shape stays the same, and so does the size. Solids, exactly. Just like this ice right here, right? This, I can't even grab it, it's too slick. This ice, if I kept it below freezing, wouldn't grow, it wouldn't shrink, it would stay the same shape and volume. But since it's in a room that's about 70 degrees, it's not going to stay solid very long, right? What about a state of matter that has no volume and no shape? A gas, exactly. Does anyone remember what we call an ionized or charged gas? It's the highest state of matter we're going to talk about?
Plasma.
Plasma, exactly. All right, next up, let's talk about some phase changes. Who can tell me what a phase change is? What is a phase change? That's what we're doing in our lab today. Change from one what? State of matter. To change from one state of matter to the next is a phase change. So what do we call the phase change from solid to liquid? It's not the B word. It's not the S word. You guys know this. Solid turning into a liquid. Melting. Melting. Oh, come on, guys. This should be review. This should be review. Solids going into liquids is melting, right? What about liquids turning into gases? Evaporation will work. There's one word that covers the other 2 we talked about. Y'all remember that? Where I drew the one word and then I put 2 words below?
Vaporization.
Vaporization. That is the process of going from a liquid to a gas. Now, if vaporization takes place at the surface of a liquid, we call that evaporation. If vaporization takes place inside the liquid, we call that
Boiling.
boiling. Exactly. All right. Whenever we take a liquid and turn it into a solid, Is energy going to be released or absorbed? Well, we're going from a liquid, which is a low state, to a solid, which is a lower state. Released. Y'all want to know how I remember this? Watch. Imagine that this graduated cylinder is a cylinder full of energy. All right? And as you move up, you move into higher states of matter. So down here at the bottom, what would we have? Solids. What comes after solids? Liquids. And then gas, and then plasma. So if you need to remember whether or not energy is released or absorbed, think about the column. If I'm going to go down in energy, I have to release energy to go down because I have all that energy stored up. Right? So if I'm going to go down states of matter from a plasma to a gas, to a liquid, to a solid, I have to release the energy so it can go down. If I'm going to go in a higher state of matter, I've got to add energy to it so that that energy level goes up. And we're going to do that today. You're going to see all 6 changes of state right here in the lab today. I can't ionize a gas, unfortunately, because I don't have enough electricity, and it's incredibly dangerous. Sounds like fun, but can't do it. Sorry. I do have some plasma for you to look at, though. Next up. What if we go from, let's say, a solid to a gas? Are we going to absorb or release energy? Absorb, because we're going up, right? So bring it in and go up, release it to go down. All right? You guys got that? Okay. Make sure you've got those notes because you can use these notes on the quiz you're going to have at the end of this lesson. All right.